Okay, hey everyone. I'm Ludwig. I'm excited to be here today, at least virtually, and tell you about work my research group as part of the larger open source AI community has done in the past few years in multimodal learning. And just to make sure we are all on the same page here, let's first clarify what we mean by multimodal learning. So broadly speaking, multimodal learning is about training machine learning models that can use multiple input modalities, for instance, text, images, and audio. And two very common examples of multimodal learning that are currently widely studied are understanding and generating images. To be a bit more precise here, what do I mean by understanding and generating images? Understanding images typically means you feed in the image into the model, and then the model produces some description of the image. For instance, a simple classical task is image classification. Image goes in, and then you produce the correct class label, like golden retriever here. And then the other way, going from text to image, this is image generation. I'm sure many of you have seen an example of this in the last few years. For instance, here, a description of this picture, a painting of a fox sitting in a field at sunrise in the style of Claude Monet. And then with a good model, what you get as output is a very nice picture depicting exactly that. Cool. Okay. So this is multimodal learning. And if we look at sort of like research progress in multimodal learning over the past few years, one key date is January 5, 2021. And this is when OpenAI released two very important papers, the CLIP paper and the DALL-E papers. And these two papers really pushed the state of the art a lot in multimodal learning. So specifically, CLIP made image understanding a lot better, a lot more universal, led to large gains on various robustness benchmarks. And on the other side, on image generation, DALL-E demonstrated for the first time that you can do flexible text-guided image generation. So these were really impressive pieces of research, but the catch was this was not sort of like broadly accessible, both in terms of the data scale, the compute scale. For DALL-E, the models were not released, and for CLIP, the models were released, but not the training code. And so in order to make sure that we in the open source research community could sort of like do similarly cool research and multimodal learning, my group and others build a lot of tooling, training code data sets in order to catch up to the state of the art there. And this is what I want to talk to you about in the next of like, I guess now 8 minutes. This is a journey through 2 years of open source AI for multimodal learning. And we'll start with the beginnings of OpenCLIP, because this is what I know best. This is what my research group started. And the goal here was to enable my group and the broader research community to train CLIP-style models. And we started out with this just after the CLIP paper came out in early 2021. A few of my friends, collaborators, and I were very impressed with this. So we reached out to Alec and Chung-Wook, the first authors on the CLIP paper, because they built on our work. They used our evaluation framework and achieved very nice results in this evaluation framework. We were like, hey, can you guys help us get started training open source CLIP models? And they were actually quite helpful and told us a little bit about how they went about training their own CLIP models. So this was the starting point. And then a friend and collaborator, Nicolas Calini, and we built the first training code and the first training set. So Nicolas still is at Google. I, at the time, was doing a gap year at the Toyota Research Institute. And sort of like, this was a good start, but things really started to accelerate when two really amazing grad students joined, Gabriel and Mitchell. By now they have graduated, but basically these were the first collaborators that had at UW, and this was a very, very nice collaboration. And they took over developing OpenCLIP from Nicolas and me. And then over the next couple of months, Mitchell and Gabriel did an amazing work figuring out all the intricacies of CLIP-style training, and we could match, sort of like for the first time, the OpenAI results in a training setup on 8 GPUs. So this was really good. This demonstrated that our OpenCLIP codebase could train CLIP models, at least at this scale. And then we made this public, released it, put it on GitHub, and we hope that other people would sort of like start helping us and we could build out from there. And the nice thing is that this exactly happened. So one important team member who joined soon thereafter is Kate. Kate, at the time, just started his undergrad actually at UC Berkeley. He's also fantastic. And he helped us scale OpenCLIP from single node training to multi-server training. And then Ross Whiteman also joined, who's also a big contributor in open source computer vision. And we did the first exploratory experiments now at a larger scale on the Joule supercomputer. Then we scaled this up to about 256 GPUs to demonstrate that we can actually efficiently use compute at that scale. And then we got together with people from LAION, our first grant to use the supercomputer at a larger scale, about 340,000 GPU hours. And we trained the first models on about 400 million images. And I already mentioned LAION. So I forgot this in the first point here. In late 2021, the LAION team formed independently, and then we connected because they had overall the same goals. They started with the training set. We started with the training code. So this was the beginning of a very nice collaboration. And then a year later, in June 2022, OpenCLIP had more than 1,000 stars on GitHub and became mostly community run. And one piece of course, if you want to train large-scale models that I already mentioned, is the LAION 5B dataset. This was another big open source collaboration. As the name suggests, the goal here was to build a billion scale, specifically 5 billion image text pairs, a billion scale dataset. And this was about 50 times larger than the prior state of the art in open source datasets. And one way to validate that LAION was actually a good training set was exactly to train CLIP style models. So here you can see a comparison. If you train a B32 scale CLIP model on OpenAI, this is what they did internally, and on our training set LAION, then you get almost the same accuracy. So this was a very nice proof of concept here that LAION is indeed a training set that supports training large scale AI models. As a result, the LAION paper won a best paper award at NeurIPS 2022 in the datasets and benchmarks track. And LAION 5B has become the training set for a lot of important work in multimodal learning, for instance, stable diffusion. Okay, and just quickly summarizing what happened since then in OpenCLIP. When I checked yesterday, by now the repository has 9,000 stars on GitHub and has become the most widely used implementation of CLIP models, open source CLIP models. And by now our best checkpoints are substantially better than the checkpoints that OpenAI released back then. And yeah. There are many more statistics here, it's become widely used at companies, many downloads per day, and so on. And for instance, as I already mentioned, not just LAION was used in stable diffusion, also OpenCLIP offers the language guidance component for stable diffusion. Another application of LAION 5B obviously was training stable diffusion models. They've become very widely used as well. But in the interest of time, we need to move on here quickly. And I want to tell you what we did after LAION 5B. And because there's a catch here, I told you at the B32 scale, we could train very nice CLIP models that are as good as the ones from OpenAI. But as we scaled up our training runs, we noticed that as we train larger CLIP models, specifically L14 CLIP models, the gap to OpenAI started to increase. So for instance, here on the ImageNet dataset, at the L14 scale, we have a 3 percentage point gap to the OpenAI models. Then on ObjectNet, another widely used test set, we have a 9 percentage point gap to the OpenAI model. So this was a bit of a bummer. So LAION was a good data set, but not quite there yet compared to the OpenAI training set. So the big question was, how can we improve LAION? And in order to answer this question, we set up basically a competition, a benchmark focused on training data curation. This was, again, a big collaboration with many amazing contributors from open source AI, various universities, and so on. And again, in the interest of time, to cut a long story short here, one key point that we could make in this DataComp paper is that this benchmark we set up does indeed support developing high-quality training sets. So the baseline that we produced as part of our benchmark, the DataComp training set, for the first time enabled training an L14 scale CLIP model to an accuracy that was higher than the one released by OpenAI. So basically, it's not just beating LAION 5B, it's also for the first time, or was the first training set to beat the OpenAI performance numbers. And again, this has become widely used by many large companies such as Apple. And you can also look at these performance gains in terms of compute improvements. So performance gains you see at the L14 scale correspond to roughly 9x improvement in training compute. Okay, we're almost out of time. So one last thing that I want to tell you about very quickly before we wrap up is DataComp for language models. So everything in this talk was about multimodal learning. After we did the DataComp for multimodal learning and realized there's so much still to be gained from building better training sets, we were curious if the same is also true for language model training. And the answer is indeed yes. So we just put this up on arXiv a couple of weeks ago, DataComp for language models. And again, these are results I'm very excited about because as part of this competition, this data-centric competition, we could train the best open data language models currently available. And they're the first open data models that are matching or roughly in the same ballpark as Mistral 7B and Llama 3, the 8B version. And compared to Llama 3 8B, we are getting almost the same performance using 6 times less compute. Okay, cool. But now we are almost out of time, so we need to conclude. As I mentioned, there's been lots of nice progress on open source AI for multimodal learning over the past few years. And one sort of like key factor in the success here, I think, has been to have a lot of collaborators distributed across many different institutions work together on these larger projects like LAION 5B, OpenCLIP, and DataComp. Okay, and on the research side, one research direction I'm very excited about is data sets. Obviously, large training sets play a key role in advancing AI, and they are often built in a decentralized manner. In the end, a lot of the training data we use for these state-of-the-art AI models come from the internet, and the internet is built in a very, very decentralized way. As a result, I think there are many interesting research questions here. Since there's so much data on the internet, we are far from exhausting all of it. How do we create good training sets from the internet? And then at some point, we'll probably run out of data if we use all of the internet data, or we want additional complementary data. And how do we do this in a distributed manner? How can we gather additional training data for training open source AI models? Cool. So thanks for listening. And I'm happy to answer questions. Unfortunately, not live, but feel free to send me an email. Bye.